Okay, let's do our 4-4 inscribed angles of a circle note. So the term inscribed angles is a new vocab word here. So it says an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So looking over here in this figure, we have circle G, and we have these two chords here. ED is a chord and EF is a chord. Notice that E is on the outside of the circle there. So we are forming this angle DEF. So this is different than a central angle that we did in lesson 2. The central angle, the vertex was at the center. Now we're pulling that angle back so that it's on the outside of the circle. So now we have a minor arc DF is the intercepted arc for the inscribed angle DEF. So we have arc DF there. Taking a look at our inscribed angle theorem, it says if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So recall from lesson 2 that if we had a central angle, the arc measure was the same as the central angle. Now our arc measure is going to be related to the inscribed angle, that instead of being the same, it'll be half of it. So for instance here, this example says that arc DF is 90. So right here, the measure of arc DF is 90. So this right here is 90. It says to find angle DEF, so this angle right here. So that means that we're just going to plug into our formula here to find the measure of angle DEF. It says it's 1/2 of the arc. So half of 90 is 45. So this angle right here is going to be 45 degrees. This green arc is 90 degrees. So the inscribed angle formed by that is half of it. It's 45 degrees. So you guys are going to be working on a lot of problems that have to do with that relationship of knowing that if the angle is 45, you double it to get the arc, or if the arc is given, you divide by 2 to get the angle. One thing that's not here that I know that you're going to need to know is just to make note that if you have a semicircle, you know that that's making the arc 180 degrees. So therefore, the inscribed angle there would be 90 degrees because it's just that relationship there. So be looking for that if you're given a semicircle. The next thing says angles of inscribed polygons. It says an inscribed polygon is one whose sides are chords of a circle and whose vertices are points on the circle. Inscribed polygons have several properties. So looking here, we have circle R. And then inside of it, inscribed, we have this quadrilateral ABCD. So this quadrilateral is going to have a lot of different properties. It says an inscribed angle of a triangle intercepts a diameter or circle if and only if the angle is a right angle. So that's kind of what I was talking about here with a semicircle. And then if a quadrilateral is inscribed, so we have our quadrilateral here, ABCD, then opposite angles are supplementary. So meaning that angle B and angle D here, those are going to add up to 180 degrees. Angle A and angle C will be supplementary. They will add up to 180 degrees. So let's write that there. So angle A plus angle C will equal 180 degrees. That's what it means to be supplementary. And angle B plus angle D will equal 180 degrees. We know from previous lessons that the degrees inside a quadrilateral is 360. So that makes sense that the opposite ones would be supplementary for when we're inscribed in a circle specifically. So that's written right there. Let's take a look at our last example here. We are given this circle inscribed